This is going to be chapter 9.4, approximate solutions of differential equations. So far we've talked about two different types of methods, separation of variables and integration factor to solve first order differential equations. So in this video, what we're going to do is we're going to try to approximate the solutions to a differential equation. And it's called Euler's method. It's sometimes called the polygon approximation. So basically what it says is that if you have an initial value problem, so let's say, for example, we have this differential equation, and you have an initial condition, so we know what y of a equals y0, we can try to approximate the solution by this iterative method. So let me kind of explain a little bit of what this is. So let me give you first kind of like a little of abstract intuition of what this is, and then I'll give you a little bit something a little more concrete. So let's start off first with the solution. So let's say this is x and this is y. So let's say we start here, okay? And let's say this is my solution, okay? So this is the solution to this differential equation. Okay, so this is just y of x. Okay, so basically what I'm doing is that we have this differential equation. Okay, so this is a solution. We're trying to figure out what this guy is, this blue line. But now I don't have the blue one. Okay, what I actually have is the red one. Okay, I have y prime is equal to some function of g of x comma y. And we also have an initial condition, ya is equal to y0. So that means when x is equal to a, my y is equal to y0. So we're starting here. So this is known to us, okay? This is the only thing that we know about our solution, okay? Now, what other thing do we know? Well, we know what the derivative is, okay? We know that the derivative is going to be g of x comma y. So basically what I'm doing is if I know the x value, I know the y value, and I know the slope, okay, at that particular x and y, well, I can just find the equation of a line, y minus y1 equals m times x minus x1. Okay, so I can just do that. Okay, so if I move the y1, I get y is equal to y1 equals, plus m times x minus x1. Okay, so this is going to be the change in how far am I changing my x value. So let's say I'm changing it by 1 unit. Okay, so let's say I'm just moving it over 1 unit. So basically I can try to figure out what this new y value would be by figuring out this equation of the tangent line. So I'm going to try to find an equation of a line. Okay, I'm going to find an equation of the line. Okay, so now I'm going to find a new y value, which is basically this y value. So this is a new y. So maybe let me call this y1. So I moved over 1 unit in the x direction, and now I'm going to get this new y1. Now this isn't quite y1, or the true value of y in the solution, but it's kind of something really close to it. And now I have a new initial point. I have another one. So now what I'm going to do is that I'm going to do the same thing, but with this new y value, make another equation of the line, move 1 unit over, okay, and then I'm going to make another solution, okay, another equation. And what I'm going to be doing, I'm going to be moving it over and over again. And hopefully what happens is that this will get really, really close to the true solution. That's kind of the gist of it, okay? So if you got it, that's great. If you didn't, it's okay also. So I'll also show it on Desmos a little bit of what exactly is going on. But basically what you're doing is that you're starting off with your differential equation. You're starting off with a y value, okay? Finding the equation of the line. And then your x value is going to be moving h units. So h is basically how far do you want to move. In this case, we're moving 1 unit over. Okay, so when we move 1 unit over, then we get our next x value. Usually the way that we want to find our h value is using this formula, h equals b minus a over n, where n is the number of line segments. So basically, you can kind of see why this is called the polynomial approximation. If you want maybe 4 line segments, well, you will have, here's 1 of them, here's 2, here's 3, and here's 4. Okay, so that's basically the 4th line segment. Okay, so that's kind of the gist of a little bit of Euler's method. You're just basically finding the equations of lines using these points and trying to approximate this blue line. So what I'm going to do in the next video, I'm going to do a couple of examples because I wanted to give you a little bit of the intuition behind Euler's method. And then we're going to do, and now we'll do a couple of examples so that you can see how this is useful.